Perhaps the most commonly used chemical in my gold refining business is muriatic acid, hydrochloric acid, also known as HCl. It is a dangerous liquid. However, it is used throughout industry and in commercial applications and in contracting applications. It's important not to fear it, but respect it. That means be smart when using it, have the right eye protection, the right respiratory protection, the right skin protection, and backup plans like fresh water and a base such as baking soda, just in case something goes wrong. And we will discuss that later. Hydrochloric acid, $10 a gallon, very common. It is absolutely very important in refining gold. Hydrochloric acid is used to make copper chloride 2, also known as acid peroxide, AP, which is the method that I use to remove gold from boards. In the second stage, we use muriatic acid to make aqua regia, and that is going to be to dissolve and purify the gold. Muriatic acid is my most common chemical that I use in this industry. This next chemical is nitric acid, which is critical to make aqua regia to dissolve the gold. It too is very dangerous and requires all the safety precautions used with hydrochloric acid: eyes, skin, nose, respiratory, and have a backup plan. Lots of water and a base such as baking soda to remediate a problem if it happens. Very dangerous, but again, if you're smart with it and you go slowly, you should have no problem. Nitric acid, just like hydrochloric acid, is not flammable in its native state, so there's something good. However, mixing acids with unknown chemicals can cause an explosion. We don't do that in nothing but gold. Nitric acid is much more expensive and sometimes not available in other countries. It can run anywhere from $30 to $120 depending on the size and the concentration. Normally 67% concentration ought to do the job. It is a dangerous chemical. Got to be on your guard. In some cases, you may want to use a substitute for nitric acid, and what you can use is sodium nitrate, which I have used successfully to produce a bar at 99.9% pure gold. It is an adequate substitute for nitric acid. It's much less expensive, and in some countries, nitric acid is very difficult to obtain. So I have used sodium nitrate successfully in the past. Hydrogen peroxide is an inexpensive oxidizer which is used to kickstart the acid peroxide process to remove the gold foils from the edge connectors. It's very inexpensive, probably $4 to $5. And the trick with the hydrogen peroxide is to just use a splash of it when you make your first batch of acid peroxide. If you use too much, you will start dissolving the gold, which may or may not be your intention. But what I do is I mix a shot of this with several gallons of this, add a bubbler, and the acid peroxide process begins. Very inexpensive, fairly safe. It's needed only if you're going with the acid peroxide method or if you're using it to dissolve gold. You've got to choose before you add the hydrogen peroxide. If you add too much hydrogen peroxide, you will dissolve the gold, which may not be your intention. Once you have dissolved the gold, you need to perform a very simple test to ascertain that there is indeed gold in solution. In solution means it's dissolved. And there's a very simple, inexpensive test called stannous chloride test. One of these dropper bottles costs about $5. A lot of people can make them. I don't make them, I buy them. A simple drop of your solution and a drop of this liquid will determine if you have gold or platinum, sometimes palladium, and the concentration by the darkness. This is crucial. Every refiner needs to have it. This group of fellas is the secondary group of chemicals that are required further on down the processing line. A few moments ago, I mentioned the stannous chloride test. Stannous chloride has a shelf life and goes bad depending on how you treat it. It can be bad, it can go bad and give you false positives or false negatives. And the way I check the checker is I reserved some chloroauric acid here, which is gold in solution. I am 100% sure there's gold in there. So what I will do is I'll put a test strip in there, put a drop of stannous chloride on the test strip. If it turns dark brown, I know my stannous chloride is still good. I keep this. I probably got 10,000 tests in here, considering I'm taking one drop out at a time. And I put a little aside. The worst thing you want is bad stannous chloride. This next item is called stump out, which is called sodium metabisulfite. And you can get it at the hardware store for maybe $10, $12. And this is critical to bring the gold in solution back to metallic gold. For instance, if I took a teaspoon of this stump out and put it into my test solution, it would turn brown and some gold would fall to the bottom. Not sure how much is in there, but this is critical to bring the gold out of solution to a metallic state by which you can then collect it. There are other types of precipitants. This is a selective precipitant. It grabs just the gold and drops it down. It leaves everything else in solution. There are other selective precipitants, but I use stump out. This one here is critical. Get it in a Home Depot or hardware store, maybe also $10. It's called sulfamic acid. Sulfamic, not sulfuric. Sulfamic acid. What it does is during the end of the aqua regia process, it is used to denox the solution to remove the extra nitric that might be in the solution. All the nitric needs to be removed from the aqua regia before we precipitate out the gold. Very cheap. It needs to be added warm. We can talk about that in future videos. Sulfamic acid, very important. It'll drop the lead and it will also remove the excess nitric in your aqua regia. This here is just good old pH test strips to know where you're at certain points of the process. Very cheap, maybe $5 for 100 strips. Sometimes you need to be acidic, sometimes you need to be neutral, and that will tell you. Very cheap. This one here needs no introduction. It's just plain old distilled water. I only use distilled water at the end of the process when I'm cleaning up my gold and getting it ready for melting. It's not required throughout the whole process, just at the end. This one here is a kitchen favorite. It's pure baking soda. It's called sodium bicarbonate, and it's basic, and it can be used to neutralize acids. That's done at the end when you're neutralizing stock pot after you're removing your precious metals. It needs to be added in a certain way. We can talk about that in the future. Sodium bicarbonate. This one here is a pool base. This is sodium carbonate, a little more basic than the sodium bicarbonate. Sometimes I just want to change the pH quicker, and I'll use sodium carbonate rather than sodium bicarbonate. So now we move into supplies. Here I have assorted buckets. This one missed the handle removal process. The handle should come off in most cases. Assorted buckets without holes. This is one of my most important tools to drop the fingers in there with a plastic hose to dip it in and out. Another plastic bucket with holes in it, nothing special. I also have specialty lids where I cut the corner out so that I can put my bubbler through there. That we'll see in future videos. Another strainer, pool strainer. It will withstand acid peroxide. I'll put small parts in there to dissolve it. This one here, bigger brother, pool filter. It does withstand the copper chloride, which is AP. No problem there. And you notice I put a plastic hose on here to be able to pull it in and out of the liquid. And this here I use for filtering at the end. I put a filter in there and I can drain the acid peroxide to get my gold foils. All inexpensive, $10, $20 here, tops. Here is one of my bubblers, nothing more than a fish tank air bubbler in here. Plugs in, I put it in an outdoor case. Not that it makes a difference, the acid will still get in there. I attached a plastic hose and I fitted it here with a assorted adapter. And I have a long tube here. This goes right down the bucket and stays at the bottom when I do my acid peroxide process. Works very, very well. These guys probably last about a year, and then they give up the ghost because of the acid that invariably gets in there, the acid fumes. But it does work well in speeding up the acid peroxide process and loosening the foils from the board. So here we have assorted glassware. We have a tall Griffin beaker here, a small Griffin beaker here, a medium Griffin beaker, and a very large Griffin beaker. You do need the large beakers to prevent boilovers and runaway reactions. It gives you a little bit of breathing room, no pun intended, when the thing starts erupting. I also have a couple of filters here, buccal filters, sure. Buccal filters there. And then I have all the watch glasses. I have a small one here. And I have a medium one here. And then I have a large watch glass here. So I do lose beakers, maybe a couple a year. And they're not terribly expensive, depending on size. Back here I have an Erlenmeyer flask. That has its application. I have a glass stirring rod, which is very important. It's about at least a ½ inch thick. And then one of my favorites, one of my absolute favorites, is this small plastic jug with the spout on it. This is what I use to decant the big buckets of AP or Aqua Regia. It works great. I can't live without this one. This one's probably $5. So that's the glassware. Of course, all of the filters need... The funnel filters need paper filters on the inside, depending on what you're filtering. And finally, with the glassware. This glassware is your second backup plan for a boil over or cracked beaker. What I do is I'll keep it underneath my beaker, and if I'm doing an experiment, if it boils over, it goes into here. This particular Corningware with the blue is acceptable to put on top of the hot plate. What's not acceptable is your wife's clear glass casserole dish, which is not meant for stovetop or hot plate topping. I put that once on a hot plate, the clear one, the pure glass, and it busted into 1,000 pieces. I'm still looking for pieces a year later. So only these can be used on top of the hot plate, not the pure clear glass ones. And finally, assorted supplies you must have to make this process work. A roll of paper towels, always handy. I also keep a garden hose ready to roll right next to me. Assorted filters, different sizes depending on the funnels I have. Slow, this one is fast. I think they're 5 inches. And then I have assorted smaller ones for the 90 millimeter diameter. Gotta have filters. Turkey baster, not only used in November. This turkey baster is great to suck up liquids. I'll sometimes spill and I'll draw it right out and put it back in the beaker. Gotta have it. It's probably $10. It's pretty rugged. It hasn't deteriorated with all the acid I put in it. You can suck up liquids and spills that fall inside this bucket and then put it back in the appropriate container. Here's a smaller version of a turkey baster. You can draw up small liquids that way or dispense small liquids. And then here's a pipette. Simple. These are $1 each. You can draw small amounts in or nitric acid out, depending on what you're doing. Got to have them. Squirt bottle. This says HCl. There's nothing in here. Squirt bottle has a different function than a spray bottle. I always keep 2 of these fully loaded with regular tap water always near me in case there's a problem. Very important to have spray bottles for an assortment of reasons. And then I have the large filters, which I use when I'm draining the acid peroxide at the end of the process to recover my foils. I do recommend this plastic container, the white plastic container. They come white. They don't come with the nothing but gold. You have to put that on yourself. I have like 4 of these, and they're fabulous. So when I'm doing a process, I'll put the hot plate in here. I'll put the Corningware on top, and then I'll put the beaker. So I've got double layers of protection if there's any kind of crack or boil over. And a couple of items here, which I use from time to time. I have these magnets here. They're very high power magnets I use to remove unwanted iron from my material. I have a strainer here, which I use from time to time, and a mortar and pestle to grind down some items to make them into a fine powder to go through the strainer. It just makes the processing a lot easier. So after doing this for a few years, I've learned quite a lot, but the knowledge I want to share with you relative to the subject matter of this video relates to the costs that I've put into this business. The glassware is really a one-time cost. The glassware, the squirt bottles, the buckets, the hot plate, the filters, that's kind of done. Occasionally I break a beaker and I have to replace it, but that's a sunk cost. I don't expect too much more costs on that. And furthermore, the chemicals are fairly cheap, except for the nitric acid. Those you always need to replenish. The point being is that once you're established, like I am and so many other refiners, now it really becomes close to pure profit, which is going to, of course, take into account the cost of the scrap material you get. But my future chemical and supply costs are close to zero at this point.
Having attained reasonable success in refining gold from electronic scrap, my goals are quite clear. Number 1, to continue to refine safely and responsibly. Number 2, to continue to find the scrap at very low prices. Number 3 is always continue to learn. And number 4 is to share what I've learned with viewers. Thank you for watching. Please subscribe and comment as you feel appropriate. Thank you.